Hello, I'm Megan Estrada, and this is Module 2, Question 1, Valid Brackets. In today's video, we are going to go over 4 key points, the first one being understanding our problem statement, the second one being brainstorming a solution, the third one being actually solving the problem, and the fourth one being improving our solution if we can. Now let's get to the problem statement. So our problem states that there exists 4 types of brackets: the parentheses or round brackets, curly brackets, square brackets, and angle brackets. Suppose you are given a string S containing just the following characters, and those characters include all of the 4 types of brackets, both opening and closing. The input string S is valid if and only if the brackets are matched by the same type of bracket and in proper order. Determine if the input string S is valid. Return true if valid and false otherwise. So the important part here is to remember that we have to return true if the string S is valid. But how do we know if the string S is valid? We know by these rules over here. We need to make sure the string S is in proper order and the brackets are matched by the exact same type. And in our constraints, we can see that the string S will consist only of brackets, so we don't need to check for any letters or numbers or other characters. And we can see that the length of the string S that will be passed in will not go lower than 1, so we also don't need to check for that edge case where the length of the string will be 0. Now for the test cases of our problem statement, you'll see for test case number 1, we have an opening parenthesis and a closing parenthesis forming a pair of parentheses. You can see that since we have an opening bracket and a closing bracket of the same time, our output for this case will be true. For our second test case, you can see that we are given all 4 types of brackets from the problem statement, and in each bracket statement, in each bracket where we have an opening bracket, we are closed by the same type of bracket. So we have a proper pair of parentheses, square brackets, curly brackets, and angle brackets. So we return true. For our third test case, you can see we have a pair of parentheses, and that's just like test case 1. So far, we've got a true output. And we also have an opening parenthesis, unfortunately, and it's not closed by the same type, and it's not closed in general. So our output in this case will be false. For our fourth test case, we have an opening parenthesis, and then we have a closing square bracket. So you can see that our opening parenthesis is closed by the wrong type of bracket, thus our output is false. For our fifth test case, we have something special. We have a nested form of angle brackets, not angle brackets, but square brackets, and it's inside a pair of parentheses. Right next to that, we have a proper pair of curly brackets, and this output will be true because it's in proper order. So that definition, proper order, was really important for the problem statement. And let's dive deeper into that. So although this is true, if I had something, let's say something like an opening parentheses, opening curly bracket, closing parentheses, and closing square bracket, it's almost like what we have with the nested square brackets in the parentheses in test case 5. But we have a conflict over here. We don't have the curly brackets being properly closed inside the parentheses. In order for this to be true, it would need to be in proper order, so it would need to be something like this. Right now, this is false. This would be true. Okay. And another misunderstanding for some students would be if we were to brainstorm, we'll actually get to this in our brainstorming part, but it'll look something like if we had a test case with this type of parentheses, I'll put it right here, and this type of parentheses. So you can see it's not really closed by itself. One is just, we have a closing parentheses and an opening parentheses, and that's also going to be false. But there is a solution that some students might use, including count variables, which will not be valid, and we'll be able to go over that soon. Now, after learning about that sort of invalid solution about counting the number of opening and closing brackets, we'll do our own brainstorming. So we know that we are going to be given a string S, and let's say our string contain some number of opening brackets. We'll say closing. We'll have some angle brackets in there. Okay. So now we have 3 types of brackets. They're all opening, closing, and we know this output is going to be true. So with this string S, we know that we somehow have to iterate through the string, of course, and we need to compare all of our brackets to make sure we're meeting that proper order requirement. So we know about data structures, we know about vectors and arrays, but one of the best data structures to use here is called a stack, and I will show you why. So a stack will have something like this. And remember, we want to compare the 2 types of brackets because that's all we have. We have opening brackets and we have closing brackets. So if I wanted to compare them, I could move all of these opening brackets here, here, and here into another container, and then I'd be left with the following brackets, this, this, and this. And remember, we care about proper order, so we want to make sure that we have opening brackets for each of these closing brackets. But all those opening brackets will be in our container, in our stack. Our stack, we're not going to be limited to size. We're going to be able to push our string characters into the stack without a problem. So that's what also makes this a really good data structure. All right. So we know that we can push one type of the brackets in there. And let's say I wanted to push the open parentheses. So I wanted to check, hey, is the first character in the string in open parentheses or an open bracket? And let's say it is. So I'm going to push that onto the stack right here. So that's my first element on the stack. And it's also the top element on the stack. Now remember, there are only 2 types. 2 types. Opening and closing. So I want my closing parentheses to be somewhere else so that I can compare them properly. I'm at this point in the string, and I want to compare that with the opening parenthesis that I had stored. Now, what happens if I just took this out? I had s.I, that is bracket, and I just compared these 2, and I saw, hey, these are the same type, and they give me something in proper order. So I know that the first 2 characters in my string check out, and I can move on. And remember, we still want to move one type of the brackets in the stack, and I have another opening bracket. So I am going to push this back on, and before I do that, with that match, I want to pop this off because I'm no longer dealing with that parentheses. So now if I'm pushing back the next opening bracket on the stack, I'm doing the same thing with comparing the next closing bracket, S at I. And I'll see that I have proper order, the same type of bracket, so I pop this off the stack, and I'm done with the next 2 characters in the string. Okay, and we have 2 more brackets, one that we know is in proper order, but we are going to continue with the brainstorming and make sure that our solution might be valuable to us. So we have an opening angle bracket, so I'm going to push that onto the stack. And I'm going to take this in the string as a character, and I'm going to compare it with the top element of the stack because I've been popping things out from the stack. So I can see that it's the same type of bracket, and they both, one is a closing, one is an opening, so they match, they're in proper order. I'm done with that, pop this out, and now I have an empty stack. If I have an empty stack, then I know that all of the pairs that I have done, so I have these closing brackets. If I have an empty stack, then I know all of these pairs, all of these closing brackets have their own respective opening brackets. So I know by this stack being empty that I have my brackets that I'm given in the string S all in proper order. I know they have their matching opening bracket. So that's how I know my string S is valid. Now let's go into some pseudocode for this. Let's clear pen markings. So I'm going to relate this pseudocode with the annotations that I did previously. Remember that I mentioned wanting to use a stack as an efficient data structure. So I might just go ahead and start creating an empty stack. But the most important part of this is that we know we're going to be given a string S, and we know that we need to get in that string and start comparing and iterating through that string. So I do want to iterate through each bracket or each character, whichever word you prefer, in the string. So I'm iterating through each bracket. And remember that there are two types of brackets in the string, opening and closing. If there's an opening one, I'm going to push that onto the stack. So the opening brackets might be opening parenthesis, opening angle, opening curly, and opening square. So I would push that onto the stack. And if I didn't have an opening bracket, then I know it has to be the other type because I'm only going to be given brackets according to the constraints of the problem statement. So I'm going to be given something like this, 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 and this. So if I have something like this, any of these brackets, I'm going to go into this else statement because I no longer have an opening bracket. And once I'm in this else statement, I'm going to start comparing that closing bracket with the top element of the stack. So let's say I were to compare this element and this element. Now you can see that the closing one matches the top element, so it's in proper order, and we can remove that opening one off the stack. And that's the process of eventually having our stack being empty, having all of those ordered pairs out of the stack. If our top element of the stack does not match, we would reach this else statement and we would end up returning false because we would have a stack and we could have opening parentheses like that. And let's say we were closed by the wrong type of bracket. So this s.i, we'll do si, would be compared with the top element of the stack. And there's a mismatch, there's a conflict. So we would immediately return false because we have an invalid pair of brackets. Lastly, we are making sure that our stack is finally empty. And if it is, we know we have all of our pairs set. Our string is done with the iteration. Our stack is empty. All of the opening brackets are out and match with their own closing brackets. So if the stack is empty, then we know that all of our pairs of brackets are valid. Thus, we return true. So that's the point of this extra if statement once we are done fully iterating and comparing our brackets. All right, so now let's get to solving our problem and implementing our pseudocode. So we have that same pseudocode, just a little more simplified up here in a comment. And remember, we wanted to create an empty stack as our data structure for the efficiency of solving the problem. And we said that if there's an opening bracket, we'd push that onto the stack. And if there was a closing one, we'd compare it with the top element of the stack. In other words, what we just pushed onto the stack. And if we found a match, we would pop the opening bracket off the stack. But what if we didn't find a match? Then we would return false if there's no match. Or there's a mismatch, we would return false. So I'm just going to include that over here. And lastly, after our final iteration throughout the string s, we will return true if the stack is empty. If the stack isn't empty, then we are going to return false. So this will be the default. Okay, now let's get started. So again, I know that I am going to be passing in a string s, and I know I'm going to be also returning either true or false. So I'm going to use the Boolean to create a function, and I'm going to pass in that string. Okay, so we did agree on creating an empty stack, and that will be of characters because a string, the string s that's being passed in, is technically just a string of characters. So when we are comparing those brackets, those characters in the string, we are really just comparing the characters. So we have our empty stack, and we know we want to iterate through the string. So let's write a typical for loop for that. We will go throughout the size of the passed in string increment. Okay, so that's just a for loop, common for loop for iteration. Now that we have our for loop, we want to check if there's an opening bracket or a closing bracket. So if the character that we're at in the string right now is in opening parentheses, we'll do that one first. It doesn't really matter which one we do first though. Or if the character we're at is a, let's say, a square bracket that's open, or the character that we're at is, we could say, a open curly bracket, and the last one is an opening angle bracket. Okay, so now we have, if we have an opening bracket. So if we have an opening bracket, we want to push that onto our stack. So we will do stack.push s.i because that's the character that we agreed or that we see is the opening bracket. But we need an else statement because what if we don't have an opening bracket? Then we need to have a closing bracket because we can either have one or the other in our string s. So let's write an else statement. And our else statement will be if we don't have a opening bracket. So else we have a closing bracket. Okay. Now if we have a closing bracket, we agree that we want to start our comparison. So let's say if that new character that we're at in the string, if s or the index is, let's do a closing parentheses, and the top of the stack, the top element of the stack will need to be, let's write this. It will need to be in opening parentheses. So that's a proper pair that we have. The next one, we are just going to repeat this for the remaining brackets. So we have if the character that we're at is a closing square bracket, then the top of the stack needs to have an opening square bracket for that to be our proper pair. Lastly, not lastly, second to last, we will have a closing curly bracket, and the top of the stack needs to be, as we know, an opening curly bracket. And now lastly, we have a closing angle bracket. And as per usual, all of the brackets that are pushed into the stack will be considered opening brackets. So we have this. Okay, so this is if we have a closing bracket and if we have a match. And if we have a match, what do? We have to pop one off the stack because we want to eventually reach a stack that's empty. So we're going to do stack.pop. Okay, now what if we have a mismatch? If we have a mismatch, then we know the element on the stack or the element in the string don't match each other. So then we just want to return false because that's invalid and not in proper order. And an example of that is, for example, this test case number 4. So you can see that in this test case number 4, we would actually push this into the stack, this opening parentheses, but we have this closing bracket, which is a closing square bracket. It's not the same type, so when we actually compare them, we're not going to pop it off. We are going to return false, giving us our output of false. Okay, so we have the majority of the code. We have our iteration through the string. We have our comparison if we have a match, we have a mismatch, and we have pushing the opening brackets into the stack. Now we have to check if our stack is empty. We are right here. And if it's not, we return false. So let's get out of the for loop because if our stack is empty, that means our iterations are done. So if our stack is empty, if that is true, then I'm going to return true, because that means I have all of the pairs and everything is in proper order. And if it's not empty, I'm going to have false. So that's something to say if I had a stack of 2 more opening parentheses and I was done with the iterations, done with everything in my string s, then I would go all the way down here. I would come out of this for loop over here, and I would see that I am missing the closing bracket for those 2 opening parentheses, so I would return false. Okay. Now what we're going to do is test a few test cases and go through one or two of them. So I have a Boolean is valid function. So I am going to create a string, and let's try the first test case. And I'm going to pass in that string, str. And what bool alpha really does is, because I have a Boolean function over here, it's going to return 0 or 1. So we know 0 or 1 is either true or false. But instead of getting 0 or 1, I'm going to get true or false. So that 0 or 1 becomes true or false because of this bool alpha. Okay. So that's just a quick way of getting true or false or 0 and 1 in actual alphabetical form. So I have my string, I pass it in, and I'm either going to get true or false. That's going to be printed, so I am going to run it. And we get what we wanted, which is true. And it's true because we have everything in proper order. We have an opening parentheses and a closing parentheses. Now let's try all of the brackets. We'll say square, curly, and angle. This should also return true. And let's see why it's returning false. So we have each one of these. We pass in the string. Let's see. All right, so for example 2, we see that we have put that into our string str, and the output for this should be true. And if we are going to run this, you'll see we actually get false. And that is unfortunately because in these 5 test cases, you'll see that in the first one, we don't really have any spaces, but in the second one, we do have spaces. So when I'm passing this in the string, those spaces are treated as their own characters. So if I were to remove those spaces, do you remember with the constraint when we were told that we would only get brackets? So that means we're not getting spaces either. So if I remove these spaces, that should get me the right output, and it does. So for test case number 2 and 3, those are just a little incorrect, so those spaces should be gone. Okay, and again, that is according to this constraint over here. For our last edge case, as what we were talking about when we were brainstorming, that was over here when we had a closing parentheses and an opening parentheses. And we said that this is invalid because it's not in proper order. So that opening parentheses, it would need to be valid like this, but it's not. So if we were to pass this in, we should get false as well because it's invalid and breaks our requirements. Okay. So you can see that if I put this in my Boolean function, I get a segfault error. That's what this means. So the issue is likely in this statement. Let's just go line by line. So we have this closing parentheses. So we go immediately to this else statement because we have a closing bracket, one or the other. And now that we have a closing bracket, with this if statement, we should go here in this condition. But stk.top actually does not have an opening parentheses because we started with the closing parentheses. So how about we have to check if the stack is empty. And it can't be empty in order for us to go through with these comparisons. Just do that for readability. Okay. Now let's run this and see if we still get a segfault error. Okay, so we get false, which is the correct output. And again, that's just because we were accessing an empty stack and trying to pop an element off a stack that was empty. So that's why we got a segfault error. So we do need to check if the stack is empty before we go further with these comparisons. So this will be checked first. And lastly, we know that a stack is efficient for this problem. In fact, this is the most efficient and natural way of solving this problem. And if we were to go ahead and analyze this, but just a gist of time complexity, it would be linear time, where n is the length of the string. And that's because we're efficiently using a stack for our data container, and we're just using a for loop to iterate through the string that's passed in our function before going through our comparisons. So again, this is very efficient for our problem statement. Okay. So far, just to recap, we have covered understanding the problem statement at hand. We covered going back to the constraints. We covered brainstorming invalid solutions that could be possible. We also went over pseudocode and implementing that pseudocode into real code. We went over some test cases and an edge case. And we also went over a segfault error with that edge case. All right, I hope you enjoyed that video and see you next time.